Hello everyone, welcome back to another exciting chemistry video lessons. Right now, in this video, we're going to be talking about the Kohlrausch Law of independent migration of ions. We'll talk about the law and also talk about the calculations that are involved. Now, before we enter the calculation, where I will break it down for you, let us state the law. Or what does the law state? The law simply states that at infinite dilution, right? We go at infinite dilution, every ion makes a definite contribution towards the molar or equivalent conductivity, irrespective of the other ions that are associated with it. Now, this is what the law states. Then we'll have to go straight to the question to start solving it. But before then, let me erase the board to create more space to explain for you how the calculations are done with ease. Now look at it, it's simple. Now, I don't want to talk much, but basically there are two major compounds that are utilized under Kohlrausch Law, even though there are others. I just want to go straight to the question to start solving. But before they look at it, we should understand that if we make it of a weak acid and also a weak base, and the parameters given to you to calculate for the infinite dilution, right, of this acid, now it is simply just follow the pattern for this acid. It can be benzoic acid as we have here. It can be any acid. It will be, if this is dilution here, so this is the acid here, for example, it will be the conductivity, right, the equivalent conductivity or molar conductivity of, first of all, the strong acid, right, plus the equivalent conductivity of the salt of the weak acid, right, minus the equivalent conductivity of sodium chloride, which is the salt. Now, this is just the pattern for all questions that are relating to this aspect. Exactly. Now, if we talk about that of the weak base, which is let's say molar conductivity at infinite dilution, ammonium hydroxide is simply equal to, follow the step now, the molar conductivity of what now? This of ammonium chloride, right? The same pattern, plus molar conductivity of the base minus molar conductivity of the what now? Salt. If you observe, the last part that you're subtracting from is always the pure salt, the normal salt, right? So that is just it. So these two formulas should be in your head, because this is the pattern you will be following in solving questions under this aspect. So let me now erase the board so we can solve this simple question. Let me erase the board now. Okay, simple. So what do we do? I'm so excited with this question. Now, they said the equivalent conductance at infinite dilution of the following compounds are as follows. These are what you were given. So this is sodium, what now? Benzoate, ACl, sodium chloride, and you were given their what now? Their equivalent conductivity here. They said calculate the infinite dilution, right, of the equivalent for benzoic acid, which is what you are seeing here. It's simple. Infinite dilution of benzoic acid, right, is equal to same pattern here, right? So here becomes ACl, first of all, of the strong acid, plus equivalent conductivity of the what now 6,6H5, the pattern here, minus the equivalent conductivity of sodium chloride. So what do we do here? Simple. That of the ACl here is 426.6 plus that of the sodium benzoate here, which is here, is 824 point, okay, just 824, plus that of the salt, which I'm to subtract from, is 126.5. So when we subtract here 426.6 plus 824 minus 126.5, the final answer becomes what now? Come in. Minus 126.5, this is 1124.1, and that is the final answer to this question. And this marks the end of this particular question. Do well to like, share, and subscribe, and also comment. Thank you, and God bless you.